Today we are going to discuss a very important report released in South Korea during the 48th meeting of the Intergovernmental Panel on Climate Change. That is the highest body looking after the climate change scenarios, global warming scenario at world level. It is an intergovernmental framework meeting. They particularly brought out this report, and name of the report is bringing down and stagnating the global temperature to 1.5 degree centigrade. Then after that, a very important event took place in Poland, which is known as COP24. COP24 also discuss about the various climate change issues, but broadly I would like to bring before you a very important statement that COP24 is not able to bring out a very, very important roadmap for achieving the global warming target of 1.5 degree centigrade from 2 degree centigrade. So this session is very important, particularly for assessing the impact of global warming, how we can restrict the global warming to 1.5 degree centigrade above pre-industrial level, and related global greenhouse emission pathway, containing particularly this a few important points I would like to bring in the background of this report, because the conference, this was taken by the 21st Conference of Parties of the United Nations Framework of Convention of Climate Change to adopt the Paris Agreement. As you know, this 2015 a very important landmark commitment given by the global community. No doubt we have several threats also coming from different sources, particularly after decision of United States of America to withdraw from the Paris climate negotiation. But the few important point we should remember that China, India, European Union, they are committed to implement this agreement, Paris Agreement, and many countries are taking an important step in this direction. But I would like to mention that the recent COP24 in Poland, not a very substantial commitment was taken, and so a very important landmark is missing from the discourse of the COP24. IPCC accepted, IPCC, first I would like to tell you, we have the WMO, World Meteorological Organization, then we have under the WMO we have WCRP, World Climate Change Research Program, and for implementing the World Climate Change Research Program we have the IPCC, Intergovernmental Panel on Climate Change. So IPCC accepted the invitation in April 2016 and prepared this special report on the impacts of global warming of 1.5 degree centigrade above the pre-industrial level and other related greenhouse gas emission pathway. This report is a very important, particularly also not only for improving our understanding about the greenhouse gases, but also the non-greenhouse gases in the context of strengthening the global response to the threat coming through the climate change, sustainable development, and efforts to eradicate the poverty. By 2030, I think we have to reduce our 45% CO2 from the pre-industrial level, and by 2045 we have to bring down to the zero level. So it was expected that the COP24 will give a clear-cut direction, but I would like to tell you that not even the financial, not any reporting mechanism or performance, reporting mechanism, nothing decision was taken on, particularly on the coal related thermal power plants. I would like to tell you that climate change and global warming is a result of both natural and human factors. But what is the most important is anthropogenic activity. Anthropogenic, so that is why it is called the anthropogenic climate change. Human, it is, but some other crop, earth rotation, mountain building process, volcanic activity, several other, changing input from the sun, changing nature of water and air, one can relate many natural factors also. But human activities are largely responsible for this. And human activities are estimated to have caused approximately 1 degree centigrade of global warming above pre-industrial level. And if you see the range is between 0.8 degrees centigrade to 1.2 degrees centigrade. So more or less we have almost the little higher than the few places little higher than the 1 degree Celsius, otherwise we have the less than 1 degree centigrade global warming. But it is likely to reach, and global community is committed to restrict to 1.5 degree centigrade between 2030 and 2050. If it continue to increase the current rate, I think it may go beyond that. So we have to restrict to 1.5 degree centigrade. Few points here I would like to mention and share with you, like anthropogenic footprints and trends. We have to see this, how reflecting the long-term warming trend since pre-industrial time. Observed global mean surface temperature for the decade 2006 to 15 was 0.87 degrees centigrade, and likely between 0.75 degrees centigrade and 0.99 degrees centigrade, higher than the average over the 1850 to 1900 period. That is the base. If you globally speaking, as you know, we have a lot of variation in the changing nature of these increase and of global warming. But very broadly speaking, I would like to tell you that increase recorded almost 0.2 degree centigrade per decade. So if you will see this trend, it is not very high, but it has a lot of the impact. Now through this map you can see the total changes occurring in different period, December, January, February, that is the, then we have blue, it is a March, April and May, where we have the greatest warming period. Then we have the June, July and August, the green period, where we have only in the southern hemisphere. But if you will see the September, October, November, then we have a lot of the changes taking place in different part of the world. But the one important point here I would like to mention, that you can see the December, January, February means the warming particularly recorded during winter time, particularly in the regions like Alaska, northern Canada, Siberia, part of Siberia, then also the mountain region, Mediterranean region also, and then the mountain regions of Eurasia, Asia and Africa, including, I can tell you, this China, India, Japan. So, understanding of global warming of 1.5 degree centigrade. Warming from anthropogenic emission from the pre-industrial period to the present will persist for centuries to millennia and will continue to cause further long-term changes in the total climate system. As you can see, this the continuous persistence of this will bring a lot of changes, not only of natural environment but even causing harmful for human health. It will continue to cause further long-term changes in the climate system, such as most important, climate change observed through the sea level rise with associated impact, particularly coastal flooding, and as you know, the very substantial proportion of human population living in coastal region. Even in case of India, you can see this, we have 4,500 kilometer long coastal lines, and then islands. If you will combine the island, we have the very substantial area under the coastal area, and many cities are located along the coast. Livelihood of the people is depending largely on the various type of resources coming in coastal region and also the marine resources. So, if we will have these emission continuing, then it is a very may cause a global warming 1.5 degree. Now, centigrade then can bring the lot of the various undesirable changes. Here you can see the regional warming, and particularly you can see the more warming when you will see the data of this December, January, February, you can see in the upper part of the globe, including the Canada, Siberia, the Western Europe, in the East Asia, part of the East Asia, we have the high warming was recorded in comparison to June, July and August. You can see June, July, August we have the lesser, but in December, January and February in this map you can clearly visible that clear cut recorded in the more dominant. So, northern hemisphere is receiving the more annual average warming. Here you can see even sometime variation is more than 2 degree in some places, centigrade, increase of the area, but few places even we do not have the human habitation. But it is very important to see that it may convert these hazards and risk extreme events may convert into the disaster when it coming and meeting with human habitation. More closer view I would like to present through this diagram, particularly taking the 28 May 2018 this killing curve CO2 concentration, and here you can see this how 1000 years of age the trend was so static, but in recent years it is so rapidly increase the CO2 release, So you can understand from your own perception that the most of the problem we are getting at present due to this CO2 release, and global warming is very much linked with this. It is very important to understand the state of warming. Warming greater than the global annual average is being experienced in many land regions and season. So here I would like to mention about the in particular season, and more specifically I would like to tell you that the winter season, and then also the many regions, particularly in the northern hemisphere, including 2 or 3 times higher in the Arctic region. Warming is generally higher over land than over the ocean. So if you compare the land and ocean, then also the warming is generally higher over the land, largely due to the release of the CO2, various anthropogenic activity, high aerosol concentration on the Earth's surface area. There is more warming, global warming found over the land surface than the sea. Trends in intensity and frequency of some climate and weather extremes have been detected over the time spans during which about 0.5 degrees centigrade of global warming occurred. So wherever we found this the increase of 0.5 degree, one can see lot of the unusual events, extreme events we are getting in different part of the world. And now you can see this what happened in recent years. Several unusual events like Kerala flood, Jammu Kashmir flood, Chennai flood, even flooding in the mountainous cloudburst particularly, and flooding in the desert area. These are some of the important examples. It is very important to identify a different type of the risk factor. Risk is a ultimate outcome of the vulnerable situation, and what are the vulnerable situations? Extreme temperature, extreme events, extreme rainfall. Climate related risk for natural and human system are higher for global warming than the 1.5 degree centigrade. So but in lower than 2 degree centigrade. So if you will see this the prediction, when we will have the 2 degree centigrade, probably we will have the stabilized type of situation, and we will have the more risk in the 1.5 degree centigrade. These risks depend on the magnitude and rate of warming. So there are several factors responsible, and it is very important to examine the influencing factor for this warming of 1.5 degree centigrade. We have rate of warming, geographic location, level of development, vulnerability, and on the choice and implementation of adaptation and mitigation option. During summer at middle latitude, even sometime we recorded the increased warming of around 3 degrees centigrade. So when we go up higher latitudes, I think we recorded the more warming. It is very important to summarize here the warming induced risk regions. What are the different risk regions? extreme high temperature event, particularly first I would like to take up Central and Eastern North America, and then also the northern hemisphere part, Middle and South Europe, Mediterranean regions, South Africa, on unusual hot days in the tropics. Then also we recorded the heavy rains in high latitude regions like Alaska, Western Canada, Eastern Canada, Greenland, Iceland, mountainous region of Eurasia including China, India, part of Japan. These are where we recorded the lot of warming, particularly unusual hot days, heavy rains and extreme high temperature. But largely these warmings are the result of anthropogenic emission. Anthropogenic emission, if I am telling, largely greenhouse gases, aerosols and their precursors up to the present are likely to cause further warming of 0.5 degrees centigrade over next 2 or 3 decades or even century time scale. So, if you see the trend also in Indian context, we found the more variability in the climate than the change, reaching and sustaining net zero global anthropogenic CO2 emissions and declining net non-CO2 radiative forcing would halt anthropogenic global warming on multi-decadal time scales. So, this is the important findings brought out before this report IPCC during the 48th session of the IPCC in South Korea. Now, through this diagram, it is very important and easy to understand about, you can see this, the 1960 to 80 to 2000. So, 1960 to 80 we had the continuous increase, slower rate during 80 to 2000, but again it is a continuing in a rapid rate, and it is expected that the likely range of moderated response to sterilized pathway in global CO2 emission, and we may restrict to the 1.5 degree centigrade. Here you can see this, the CO2 emissions decline from 2022. This is the another important projection to reach net zero in 2055 to 2045, how we can bring down. Here in the second one, cumulative net CO2 emissions, billion tons, gigaton carbon dioxide, cumulative CO2 emission in pathway reaching net zero in 2025. So, these are the 3 different type of scenarios given. Then one is the non-CO2 radiative forcing pathway, watts per square meter. But we have to take a very substantial measures for that. Various type of adaptation, mitigation measure we have to take, and we have to link with the poverty eradication program. Climate related risk for natural and human system, and as you know, we have to do integrated assessment for this. What will be the impact of different scenarios, on our flora fauna, on agriculture, on water resources, on human health, on different type of the biodiversity. So impact on natural and human system from global warming have already been observed, and many land and ocean ecosystem and their services they provide have already changed due to the global warming. Already different signs and signals we are getting that even in the Himalaya, high Himalaya region, the changing nature of the glaciers, these are the glacier retreat is a response from this global warming, but we do not have uniform impact. Future climate related risk depend on the rate, peak and duration of warming. So that is why there is another scenario that maybe by 1.5 degree if we have the certain changes, but between 1.5 degree to 2 degrees centigrade will have not the same type of the impact. In the aggregate they are larger if global warming exceeds of 1.5 degree centigrade before returning to the level of 2100, then if global warming gradually stabilize at 1.5 degree centigrade. This is another important scenario coming from this report. And so that is why the peak temperature is high, particularly about 2 degree centigrade. So some impact may be irreversible, such as loss of some of the ecosystem, because due to the sea level rise, the many area will be the flooded, submerged in the sea. Here you can see this the different time period. This diagram, the global temperature, you can see the annual mean, changing global mean temperature, changing nature and rate of the global mean temperature. You can see 1860 to how we have the different type of the rate, and trend line shows the and this the whole was divided, you can see the yellow one how rapid we have increased in recent years, in last 25 years. Then if you go back 50 years, you can see this the red one, then blue one in the 100 years, then 150 years. So you can see that how rapid temperature recorded in last 25 years. You can see from this diagram very carefully, you can examine here. Here you can see this the IPCC AR5 near term projection, particularly the temperature anomaly in degrees centigrades, 1860 to the figure here you can see, and then also you can find that the projection also you can find at the M between 2016 to 2020, what will be the different type of the trend. So you can find the observational range, human induced temperature range, you can change, you can find total force temperature range. So different type of the scenarios you can find from this IPCC model. Here you can find that how the impact will be there. Explaining the IPCC 1.5 degree special report, you can see what will be the changes. Extreme heat, global population exposed to severe heat at least once every 5 years, 14%, but when we will have the 2 degree, then it will be the 37%. sea ice free Arctic, number of ice free summers, you can see at least one every 100 years in the 1.5 degree scenario, but at least one in every 10 years. So you can see this, the so frequent, how irreversible changes can take place. Then you can see sea level rise, amount of sea level rise by 2100, 0.40 meters, but in 2 degree scenario it will be the 0.46 meters. So through this you can see that the how half a degree changes can bring different type of disastrous extremes and events in our society. Just one two important figure I would like to share with you about our IMD data. Here you can see this, the temperature pattern and the rainfall pattern, and you can find that how these temperature pattern and the rainfall pattern, how these are quite variable. So it is not a change, but it is a variability. Same thing here you can find in northeast Himalayan region, particularly increase in the temperature over the northeast region. So the increase occurs uniformly over the different time periods. So every part of the country is not uniformly affected by this process. In some part we have the more impact, and many data we analyzed from Kullu Valley or the Garhwal Himalaya, and we found a very changing and variable results. So what will be the potential impact and associated risk? Climate models project robust differences in regional climate characteristics between 1.5 degree to 2.5 degree centigrade. As you might have seen this, the type of scenario presented in the earlier diagram. So these differences include increase in mean temperature in most land and ocean regions, has hot extremes in most habitated regions, heavy precipitation in several regions, and the probability of drought and precipitation deficit in some region. And whatever we are getting sign and signals, we have several examples from our own country like Kerala or Chennai flood or the Jammu Kashmir flood. I think we are getting such type of the trend. Several regional changes in climate are assessed to occur with global warming up to 1.5 degree, and so that is why it is very much related to frequency, intensity, the amount of heavy precipitation in several regions. And in monsoon region we get the heavy, in just few days, a very heavy precipitation, and frequency of drought in some regions. Number of hot days is projected to increase in most land regions, with highest increase in the tropics. Why in the tropics? Tropical Asia, tropical Africa, tropical Latin America, where most of the deforestation is taking place. These are the regions having a very high aerosol concentration and the more human activity. And so generally the impact is sea level continue to rise well beyond 2100. This model based projection of global mean sea level rise, particularly they correlated with 1986 to 2005 and suggest an indicative change of 0.26 to 0.7 meter by 2100 for 1.5 degree centigrade global warming. So you can see from how the range, average global range is 0.4, but here you can find this range is 0.263 meter to 0.77 meter, and less than of global warming of 2 degrees centigrade. So a reduction of 0.1 meter in global sea level rise implies that up to 10 million fewer people would be exposed to related risks. So you can understand from your own perception the type of problem and scenario presented, because this is present based on the population in the year 2010, and even if you will come now you see the present population, this risk will go even the more, and assuming that the no adaptation, but simultaneously many adaptation measures are being taken. Impact in marine and coastal regions. As you know, the ocean and marine environment is considered as a sink and source of the carbon. Marine ice sheet instability in Antarctica and irreversible loss to the Greenland ice sheet could result in the multi-meter rise in sea level over hundreds of thousands of years. So increasing warming amplify the exposure of small islands, and we have so many islands in different parts of the world, low-lying coastal areas and deltas, to the risk associated with sea level rise for many human ecological systems, include the saltwater intrusion, flooding and damage to infrastructure. I would like to bring before you here the one example that what happened in the last tsunami. Seawater enter into the groundwater, and you can find a very substantial change, land use change in the coastal area. So we have to see this phenomena, we have to examine carefully, scientifically. No doubt, apart from marine environment, we have impact on biodiversity and ecosystem. Of 105,000 species studied, 8% of plant and 4% vertebrates are projected to lose over half of their climatically determined geographical range for global warming of 1.5 degrees centigrade. So even if we can restrict the 1.5 degrees centigrade, then you can see how much biodiversity will lose. Compare with 16% of the plant and 8% of the vertebrates of global warming of 2 degrees centigrade. Impact associated with other biodiversity related risks such as forest fire and the spread of invasive species are lower at the 1.5 degrees centigrade compared to the 2 degree of the global warming. So I think there is no alternative to restrict our temperature increase to 1.5 degrees centigrade. High latitude tundra and boreal forests are particularly at risk of climate change induced degradation and loss, with woody shrubs already encroaching into the tundra, and this will proceed with the further warming. Population at disproportionately higher risk of adverse consequences with global warming of 1.5 degrees centigrade. Particularly, I would like to mention the disadvantaged and vulnerable population, then some indigenous people, local community, largely dependent on various type of the livelihood coming through the coastal region, and what I would like to use the word the coastal livelihood or the marine livelihood. Many eastern and western part of the country, even coastal area, they are depending on the different type of the fishing resources. Potential biodiversity impact can be seen, species loss, extinction are projected to be lower, and it is increasing. Just yesterday the National Biodiversity Report was even released, and you can see that lot of changes is taking place, and the list of endangered is increasing. List of endangered species are increasing. Limiting global warming to 1.5 degree compared to 2 degree is projected to lower the impact on terrestrial, freshwater and coastal ecosystem, and to retain more of their services of the humans. We have to see also the different type of the activity, and here I would like to bring before you the very important phenomena, ocean acidity and decrease in the ocean oxygen level. And decreasing the ocean oxygen level means will have also the impact on ocean living resources. Lot of living resources, no doubt in our country we are only using the fishing resources, but there are many such living resources available in surrounding to our country. Consequently, limiting global warming to 1.5 degree is projected to reduce risk to marine biodiversity, fisheries and ecosystem, and particularly in their function. And so then we'll have these services useful for the human being. And because on the basis of the changes taking place in Arctic sea ice and warm water coral reef ecosystem, one can guess that what is happening in our surrounding coastal environment. No doubt we have to see also the different type of the risk related to health, livelihood and food security. Apart from Arctic ecosystem, we have the dryland regions. 60% area of our country, like India, generally considered as a dryland area, where precipitation is less than potential evapotranspiration. A small island developing state. Poverty and disadvantage are expected to increase in some population as global warming increases. And so that is why we have more and more people will be susceptible to the poverty in the coastal area if we will continue or even more than 1.5 degrees centigrade. An increase in global warming is projected to affect human health with primary several type of negative, several insects, and lower risk are projected at certainly at 1.5 degree than the 2 degree, particularly taking into consideration of heat related morbidity or mortality, and for ozone related mortality if emission needed for ozone formation remain high. Another important point I would like to bring before you, urban heat islands often amplify the impact of heat waves in city, and whatever we are getting different type of trends, not only in Delhi, Mumbai, Calcutta, big city, risk from some vector-borne diseases such as malaria and dengue fever are projected to increase with warming over 1.5 degrees centigrade to 2 degree centigrade, including potential shift in their geographical range. So I think there is no alternative to restrict our temperature to 1.5 degree centigrade. Now here I would like to put before you the here you can see this the 5 regions for concern. This looking the impact and risk, generally it is coming from the IPCC. Purple indicates very high risk, and you can see the impact presence in significant irreversibility or persistence of climate related hazards. and we can have in level of additional impact due to the climate change very high. These are the different type of the regional region of for concern, and like a unique and threatened system you can see is a more extreme weather events is followed by that, then distribution of impact litage not much, global aggregate impact will be less, large scale singular event, but here you can see the unique and threatened systems is a very high purple color, red indicates severe and widespread impact risk, but yellow indicates impact and risk where we can detect. So you can see these are the very small where detectable, white indicates that no impact, Now here you can see impact and risk for selected, natural, managed and human. Particularly different type of the ecosystems are given here. You can see the more impact we have, warm water corals, very high purple you can see. Mangrove not much, but you can see Arctic region we have very high. Coastal flooding we have very high impact. Terrestrial ecosystem very high impact. So these are the some of the important, you can see the ecosystem where we are having the more large impact. No doubt we have impact also in other like mangrove, but in that area that side is a more high impact. So emission pathway and system transition consistent with 1.5 degrees centigrade of global warming, and you can see that the in model pathway with number or limiting overshoot of 1.5 degrees centigrade, global net anthropogenic CO2 emission declined by about 45% from 2010 level by 2030, reaching net zero around 2050. This is the important scenario presented. But for limiting global warming to below 2 degrees centigrade, CO2 emissions are projected to decline by about 25% by 2010 in most in pathway and reach net zero around 270. So non-CO2 emission in pathway, it is also very important to understand the non-CO2 emission that limit global warming to 1.5 degrees centigrade. So deep reduction that are similar to those in pathway limiting warming to 2 degrees centigrade. So this one is also very, very important factor. General characteristics of the evolution of anthropogenic net emission of CO2 and total emission of methane, particularly here I would like to mention black carbon and nitrous oxide in model pathway that limit global warming 1.5 degree centigrade. Net emissions are defined as anthropogenic emission reduced by anthropogenic emission. So largely how we can reduce the anthropogenic activity, fossil fuel, but during the COP24 no substantial discussion took place where how we can restrict the use of coal-based thermal power plants. That is a very important aspect I would like to bring before you. Reduction in net emissions can be achieved through different portfolio of mitigation measures, but in this direction we have not taken. Here you can see that how we can bring down this methane emissions, black carbon emissions, nitrous oxide emissions. These are some of the pathway non-CO2 emission relative to 2010 given. In this pathway limiting global warming to 1.5 degrees centigrade with no or limiting overshoot, as well as the pathway with a higher overshoot. So in this diagram one can see this we have to bring a very substantial measures, maybe through the COP or the Paris climate action, or the national government should come forward for taking different type of initiatives. It is very important to relate climate change with people, close link with the United Nations Sustainable Development Goal, because if we are not restricting our climate to temperature to 1.5 degrees centigrade, our people will be affected. So that is why sustainable development goals will be threatened. By implementing sustainable development goals, we can bring down our temperature. Mix of measures to adopt the climate change and reduce emission can have benefit also for SDG. Various national level, subnational authority, civil society, private sector, indigenous people, local community can support this type of action plan. International cooperation is a critical part of limiting warming of 1.5 degrees centigrade. I would like to tell you that the recent decision of 30 countries to not install any new coal-based thermal power plant is a very, very welcome step. So this is a very important direction taken. Adaptation, it is a few minutes I would like to discuss about the adaptation and challenge. A wide range of adaptation options are available to reduce the risk to natural and managed ecosystem. Particularly ecosystem based adaptation, ecosystem restoration, avoiding degradation and deforestation, biodiversity management, sustainable aquaculture, local knowledge, indigenous knowledge. But I would like to repeat here that the COP24, where we did not discuss about the financial provision, because developing countries require some funding even for implementing this task. Even verification methodology about the how to report about the reducing the warming level, restriction on the coal-based power plant, but 30 countries they decided that is a good, important, welcome step in this direction. Risk of sea level rise, coastal defense and hardening, risk to health, livelihood, food, water and aquaculture, and different type of landscapes like efficient irrigation, social safety nets, disaster risk reduction, risk sharing, community based adaptation, green infrastructure, sustainable land use and planning, sustainable water management. These are the important initiatives already taken in different part of the country and also in different part of the world. Adaptation is expected to be more challenging for ecosystem, food and health system at 2 degrees centigrade of global warming than 1.5 degrees centigrade. Some vulnerable regions, including a small island and least developed countries, are projected to experience high multiple interrelated climate risk even at global warming of 1.5 degree centigrade. Limits to adaptive capacity exist at 1.5 degree centigrade global warming. This become more pronounced at higher levels of warming and vary by sector. It varies from sector to sector with site specific implications for vulnerable regions, ecosystem and human health. I would like to report here a very important data with 10 years of Kyoto Protocol, CDM mechanism already implemented. The greenhouse gas reduction was 1.58 billion ton, but anthropogenic carbon increase to 10 billion ton. So you can understand from your own perception that we are able to reduce very small, but we have contributed more CO2 in the atmosphere. Global response in the context of sustainable development and efforts to eradicate poverty, that is also is a very important. Challenges from delayed action to reduce greenhouse gas emission include the risk of escalation, lack in carbon emitting infrastructure, stranded assets, and reduced flexibility in future response options in the medium to long term. These may increase uneven distributional impact between countries at different stages of development. Other global responses one can see, particularly the avoiding climate change impact of at least moving towards the 2 degrees centigrade, mitigation and adaptation synergy are maximized while trade-offs are minimized. And here I can tell you that the important step taken by India and France, particularly the International Solar Alliance, will contribute very substantially for mitigating and restricting global warming to 1.5 degree centigrade. But many more work to be done. Climate change impact and responses should be linked with the social well-being, economic prosperity, and environmental protection. This is sustainable development goals can bring not only the eradicating the poverty, reducing the inequality and the climatic action, mitigation and adaptation consistent with limiting the global warming are interrelated. I can tell you that even for the urban area, many steps taken for the green energy, energy efficiency, these are the some of the important socio-cultural and institutional dimension of feasibility we have to bring. Now here you can see that the how SDG, social and system transformation, can bring through, and we can bring the lot of adaptation, and simultaneously different type of interactive SDG we can promote in different part of the world. So indicative linkages between mitigation and SDG, particularly here you can see this the various options we have to bring, but the most important option I would like to tell you, we have to restrict the total new thermal power plants, coal-based thermal power plant, but due to the coal lobby, many countries are taking the second thought for implementing the Paris climate action. Sustainable development supports and often enables the fundamental societal and system transition and transformation, and that can bring the global warming to the 1.5 degree centigrade. Here you can see the different type of the SDG goals. You can see this starting from poverty to zero hunger to the human health, the how sustainable water management, energy efficiency, the role of vulnerable groups like gender equality, the old age people, how we can involve and we can reduce the vulnerability of the children in different part of the world. I would like to conclude now that there is no alternative to restrict our global warming to the 1.5 degrees centigrade or less. Adaptation efforts taking place around the world, including various schemes, but we need to evolve the agricultural practices, modify the agricultural process, adopts different type of the building capacity to even the building materials. The traditional use of building material will help, including making governance more feasible, flexible, and strengthening financial mechanism such as providing different type of insurance facility. While adaptation is important to reduce the negative impact for climate change, adaptation measures can prevent the climate change. And various examples like already we discussed that loss of coral reef, massive range losses, terrestrial species, human deaths, these are the things how we can minimize, and that can be done through the multi-hazard mapping, risk assessment. Generation of exposure and vulnerability data will go hand in hand for bringing socioeconomic vulnerability and resilience on the top of the agenda for mitigating the climate change. Finally, identifying mechanism and opportunity to improve exposure database and model will bring the new areas of science like GIS and remote sensing will help in this direction. Thank you very much.